I was talking about torque, and I discussed how to how to find torque for a given set of forces and a given rigid body. Right. So now we will learn today how to apply this in a problem involving a rigid body. So today we are going to talk about the Newton's second law for this time now for rotation. So if in translation the law is F is equal to ma, in rotation law should be torque is equal to I alpha. But there are certain problems here, and the problems are that moment of inertia is an object which is defined with respect to an axis of rotation, whereas torque is also an object which is defined with respect to an axis of rotation, which was not the case with M and F. So the main question that you should ask is, भाई अगर ये equation है, तो does the axis of rotation have any role to play here? Yes, it does. So you have to be careful that when you apply this equation, torque and moment of inertia must be about the same axis, right? So from wherever you are measuring, from whichever axis you are measuring torque, you must also measure the moment of inertia from that particular axis. Okay? You have to be very, very careful with this. Now, before we even sort of apply this equation, right, we are going to first talk about a special case, and that is the case of equilibrium. In this equilibrium, what happens is that summation of forces is zero. We've already seen this. But in mechanics now, when we are dealing with rigid bodies, equilibrium would imply that not only summation of forces is zero, but also the summation of torque is zero. Okay? Then we would have equilibrium. It is not sufficient to have summation of forces equal to zero to have equilibrium. So you can have a situation where the summation of forces is zero, but the summation of torque is not zero. And this would not be an equilibrium situation. Okay, so what I am going to do is we are going to rather discuss a series of equilibrium problems today. And the question that will become most important is about which axis should I find torque, or about which axis is torque equal to zero for equilibrium. And here the answer is about any axis. Right? Now this is very weird, because we saw that even if about a particular axis the torque on a system is non-zero, then you can always shift your axis to a point where the torque can become or may become zero. It is always a possibility. But when we discuss equilibrium, when the word equilibrium is mentioned, then this necessarily means that uh, talk about any and all points that you can choose. Any point that you can choose must be equal to zero. Okay? The full statement is uh, that vector है यहाँ पे. So basically, summation of fx is zero, summation of fy is zero, which we did when we were doing Newton's laws of motion. In fact, we started like this only. I told you that let's consider a situation where the summation of forces is zero, and you had to find various things. Either it was the normal reaction, or it was the weight of an object, or something else. So we are going to start in a very similar fashion. The only difference now, remember, is the concept of moment of inertia that has crept in. So not only do you have to find not only do you have to draw the free body diagram and equate it to zero, but also you have to draw the rotational free body diagram and equate the torque to zero, right? Now, if you have a choice of origins or choice of axes, because if I have said that everything is in equilibrium, that means that torque about any axis is zero. Then, is there a preferred choice, or are all choices the same? Well, theoretically, all choices are the same. However, you can be clever about this, and you can always choose. A particular point, particular axis, about which maximum number of unknown forces give you zero torque. So that when you find the torque about that point, the equation that you get will either involve only one unknown, best case scenario, or it will involve a least number of unknowns, so that you can construct your equations in a manner which will be more handleable. Okay. Okay. So let's try this. Question number one. हाँ, वही कर. ठीक, कर. Okay. So I said that if I mention the word equilibrium, or you can sort of deduce that equilibrium is there, then not only the summation of forces must be zero, but also the summation of torques must be zero. not only must the summation of torques be zero, but the summation of torque about any point must be zero. Okay? It is not that about a single point that summation of torque is zero and about another point the summation of torque is non-zero. That does not constitute equilibrium. Okay? Now, if we know that so if we know that the summation of torque about any axis is zero, then which axis should be chosen to about which to find that torque? Well, the simple rule is that you should find the torque about that point about which maximum number of unknown forces give you zero torque. That means maximum number of unknown force vectors when extended should pass through your chosen origin. हाँ रैंकिंग चॉइसेस में और भी चॉइसेस है शौनक हाँ मतलब दैट इज अ परफेक्टली गुड चॉइस आई डोंट थिंक जो मैं और भी चॉइसेस बोल रहा हूँ उसमें कोई ऐसा चॉइस है जो इससे ज्यादा सुपीरियर बट देयर आर अदर चॉइसेस वेयर यू गेट द सेम नंबर ऑफ वाह भाई क्या हुआ हम लोग सो गए क्या इतना सिंपल सा क्वेश्चन है इसका अंशुल इसका जो यूनिट्स होएगा वो क्या होएगा आपने आंसर तो बताया वो ब्रैकेट में क्वांटिटी है उसका यूनिट क्या है So I will do this. Please follow. Please pay attention. Please follow me. So I'm going to make a free body diagram first. I don't need to make the translational free body diagram because I can just take it off from here. So because of gravity, mg is acting downwards from the center of mass. There is a normal reaction N1 because of the smooth horizontal flow. There is a normal reaction. There is a normal reaction N2 because of the rough vertical wall. And there is a vertical force mu N2. Now I know its value is mu N2 because the ladder is just about to slip. Now, if you remember from our discussions in Newton's laws of motion, especially when we were dealing with friction, just about to slip का मतलब होता है that equilibrium is still there, right? Acceleration is still zero. However, the value of friction has reached its maximum value. अगर मैं ये word use नहीं करता, अगर मैं आपको बोलता कि find theta if the ladder is in equilibrium, then you could not have written mu n2 in the FBD, then it would have to be F2, right? In fact, the correct way of approaching this would be to write F2, right? So I'm going to do that. Then I'm going to later on replace F2 by mu n2. Right? So F2. Okay, so since there is equilibrium, this means that summation of forces along x-axis must be 0. कैसे आंसर निकाला? जब क्वेश्चन ही गलत दिया है मैंने।
इसमें शायद से रफ नीचे होगा ना, तो
रफ नीचे है।
सर हॉरिजॉन्टल वाले पे रफ था ही नहीं, इससे मैंने ट्राई किया, इससे थोड़ा गलत आ रहा था।
This is rough. This is smooth. Sorry about the mistake. Vertical wall is smooth. Right, now again, once again. So basically this is going to go away and I'm going to get here F1. Okay, so summation of Fx is 0. So this tells me that N2 is equal to F1. Summation of Fy is equal to 0. This tells me that N1 is equal to Mg, right? And this F1 should be equal to mu N1, since the ladder is just about to slip. So this means that N2 should be equal to mu Mg, right? Now we want to find theta. So summation of torque about any point is 0, and I think जब मैंने question गलत दिया था, so most of you identified that this point should be the point about which we should take torque. Now that the question has been corrected, the logic will remain the same, and we will take torque about this point. If we take torque about this point, then it turns out that the torque due to F1 and N1 will be 0. Any other point that you can think of? Any other point that you can think of? नहीं COM अगर लेंगे ना तो COM अगर लेंगे ना तो N2 टॉर्क लगाना पड़ेगा, N1 का टॉर्क लगेगा, F1 का टॉर्क लगेगा, 3 फोर्सेस का टॉर्क लग जाएगा। ये वाला पॉइंट जो मैंने लिया है तो देयर आर ओनली 2 फोर्सेस व्हिच विल अप्लाई टॉर्क। ये वाले पॉइंट पे 3 फोर्सेस विल अप्लाई टॉर्क, ये वाले पॉइंट पे 3 फोर्सेस विल अप्लाई टॉर्क। I just want to minimize my work. So any other point where you think that the torque will be only due to two forces? I don't think it is possible to get torque due to only one force. वो possible होना भी नहीं चाहिए, नहीं तो फिर कभी zero नहीं आएगा. और कोई point जहां आपको दिखाई दे रहा है that the torque will be only due to two forces? Can you see another point where the torque will be only due to two forces? No one? No one can see? ये रहा point. इस point पे दो आएंगे. ये रहा point. हाँ बिल्कुल सही याद है. ये point पे भी दो आएंगे. Right? So there are multiple points which you can choose depending on your convenience. जहाँ से आप minimize कर सकते हो. Let's choose point O since this was the original choice. Summation of torque about point O should be equal to 0. So this should be equal to half tertiary. So this should be equal to इस point के about torque हमें निकालना है. जैसे निकालें भाई. इस point के about जो torque होएगा that will be due to N1. It will be torque due to F1, torque due to mg plus torque due to N2. Right? Our choice is such that torque due to N1 is 0, torque due to F1 is 0, torque due to mg. Right? How do we find torque? All we have to do is we have to extend this vector, right, and drop a perpendicular from the chosen origin. And I know that this distance is L by 2, and I know that this angle is theta. So I know that this perpendicular distance is L by 2 cosine theta. So this will be equal to mg into L by 2 cosine theta. Right? And I must also write clockwise or anti-clockwise. So in this case, it is clockwise. Remember our discussion? Keep the arrowhead. You keep your pen on the arrowhead and just turn it towards the origin, and you see whether you are turning clockwise or anti-clockwise. Then sin theta होगा.
परपेंडिकुलर डिस्टेंस टू ओ ना, ओ हमारा हॉरिजॉन्टल एक्सिस है ना.
नहीं बेटा, you have to be careful. गलती नहीं करना. ये mg वेक्टर है ना.
हाँ जी.
तो ये mg वेक्टर को आपने एक्सटेंड किया दोनों डायरेक्शन में, और उसके बाद से आपने अपने चोजन ओरिजिन से परपेंडिकुलर ड्रॉप किया. So then this torque is going to be the magnitude of this vector multiplied by this distance.
Okay.
Right?
Okay, sir.
You drop a perpendicular onto the extended force vector, it has to be the distance multiplied by magnitude of the force. So in this case, this would be how much? Plus N2, और N2 को अगर हम extend करेंगे, इधर करेंगे, ये रहा length of perpendicular on N2. So this will be equal to how much? This will be equal to L sin theta. L sin theta. And this will be anti-clockwise. So basically, if you take clockwise as positive, the N2 वाला term negative हो जाएगा. If you take anti-clockwise as positive, the mg L by 2 cos theta वाला term negative हो जाएगा. In either case, our equation will give. Mg L by 2 cosine theta is equal to N2 L sin theta, out of which we can readily see that L has cancelled out, and we can write then mg cosine theta by 2 is equal to n2 की वैल्यू हमें पहले से पता है mu mg into sin theta. So mg and mg will cancel out, and I will get tan theta is equal to 1 by 2 mu. Theta is equal to tan inverse of 1 by. Sorry, थोड़ा सा space कम हो गया. ये आ रहा है, थोड़ा थोड़ा क्लियर हो रहा है कैसे करना है. Please notice that just by equating the forces to zero, you could never find the value of the angle. Just by equating the forces to zero, you could not find the value of the angle, right? Because the angle itself is a property of the fact that the body is an extended object. Okay? That angle is there because the body is a thin rod. Okay, it is a ladder, whatever it is, I don't know. The fact that this body is not a point particle gives rise to the angle theta. If you reduce this to a point particle, then you would get n1 is equal to mg, you would get n2 equal to mu mg, you would get f1 equal to mu mg. But that's it. That is the end of the analysis of this object as a point particle. It is only when you consider this object as an extended object and you are applying the concept of torque on it that you can get additional information. Right? It makes a lot of sense. A point particle cannot make an angle theta with anything, whereas a ladder can. Continuing with this ladder, another question. Start continuing. Friction on both sides. Find max value of theta for equilibrium. ओ भाई फिर से गलत क्वेश्चन तो नहीं दे दिया। क्या वो नहीं हो रहा है? हो जाना चाहिए। फिर से गलत क्वेश्चन। यश। हाँ सर। दो वेरिएबल्स क्या बोल रहे हैं? कुछ दो वेरिएबल आ रहा है। F1, right. Not inverse ड्यू पे डिपेंडेंसी नहीं आ रही क्या? रुको रुको let me work it out. So we get summation fx is equal to 0. This gives us f1 is equal to n2. ठीक है ठीक है. Let me get the answer. Summation of f5 is equal to 0. अच्छा okay. Gives us n1 plus f2 is equal to right. And talk about any point. So I'm going to choose now. I will just for variation choose this one. I don't think there is any other point which will give us less than 3 forces. No, I don't think so. So summation of torque about point 4, which is summation of torque due to n1 or due to mg or due to f1. This is equal to 0. So we have 0 plus 0. 1 and 2 is 0, 0. plus torque due to mg. mg को पहले मैं extend करूँगा, then I will drop a perpendicular, and I will get mg equal to cosine theta. And this is clockwise. Plus torque due to F1. So I will extend. Actually, I don't need to extend. Drop a perpendicular. So this will be equal to F1 multiplied by this perpendicular distance, which is equal to L sine theta. This is anti-clockwise, plus F2 L cosine theta, right? This is easy to figure out. तो ये रहा extended force, ये पूरा perpendicular distance है यहाँ पर, which is L by 2 cosine, L cosine. And this is also anti-clockwise. Okay? So this is the set of equations. And now, since theta is maximum, we should assume that F1 is equal to mu n1 and F2 is equal to mu n2. Right? So we get F1, which is mu n1 is equal to n1 plus mu n2 is equal to mg, which gives me n1 is equal to mg upon 1 plus mu square, and 2 is equal to mu mg upon 1 plus mu square. Right? And equating these two guys, we get mg L by 2 cosine theta on one side because it is clockwise, and the anti-clockwise torques on the other side. So F1, which is equal to mu n1, mu mg upon 1 plus mu square L sine theta, plus F2, which is mu n2, mu square mg upon 1 plus mu square L cosine theta. So throughout this MGL will go away. And if I divide this by cos theta, we want to divide it by sine cos theta. Yes. If I divide by cos theta, then I'll get half is equal to tan theta into mu upon 1 plus mu square plus mu square upon 1 plus mu square. Okay. Now please tell me the value of tan theta. Please tell me the value of tan theta. One minus mu square वो कॉट वाला चेक कर लो अंशुल, अगर कॉट में सेम आता है। अच्छा, ओके। साइन से, साइन यू हैव टू बी वेरी वेरी केयरफुल। हाँ,
सर
बिल्कुल सर।
tan थीटा 1/2 न्यू आ रहा है।
है
tan थीटा 1/2 न्यू आ रहा है
कैसे?
सर। 1/2 माइनस न्यू स्क्वायर अपॉन 1 प्लस न्यू स्क्वायर किया।
हाँ, तो वही तो कैलकुलेट करना है ना।
वो 2 म्यू स्क्वायर हो
अरे हाँ,
जाएगा,
वो
बस
2
म्यू
न्यू
स्क्वायर नहीं
स्क्वायर हो
लेना।
जाएगा,
हाँ
मैंने 1 न्यू स्क्वायर माइनस कर दिया, सॉरी। सही सही।
ओके। हाँ बिल्कुल बिल्कुल, यस यस, निकल सकता है। हाँ। चलो, वन फाइनल लैडर क्वेश्चन, वी आर डन, बाकी सी में दिया हुआ है। Let's take a simple वाला केस। नहीं, दूसरा केस होएगा उसमें, दूसरा कंडीशन होएगा। मिनिमम एंगल थीटा के लिए द कंडीशन विल बी दैट वर्टिकल वॉल वाला नॉर्मल रिएक्शन है, दैट विल बिकम जीरो। वी विल कम टू दिस, मतलब ये क्वेश्चन हम करेंगे, लेकिन थोड़ा डिफरेंटली करेंगे। वी विल do the question in this way, that if I leave the ladder in this position, then at what angle will the ladder leave the vertical surface? Theta, mu, smooth. So now a man is climbing the ladder. So given mass of ladder equal to m, mass of man into capital M, angle theta, coefficient of friction mu, and distance of man x, and x if ladder slips, rather just slips at this point. Another way that I could ask the question would be, how far up the ladder can the man climb? वो जो ये आंसर निकाला ना प्रतीक्षा, 1/2 म्यू and inverse 1/2 म्यू, that will be the minimum angle.
सर लेकिन हम स्पेसिफिकली वो वर्टिकल वाले का जीरो क्यों कर रहे थे?
एक मिनट का आवाज नहीं आ रही। वॉल्यूम कंट्रोल कहाँ है? हाँ, फिर से बोलो।
सर हमने आप अभी जो बोल रहे थे उसमें स्पेसिफिकली वर्टिकल वाले का जीरो क्यों किया मिनिमम के लिए?
मैंने कहाँ जीरो किया, किसको जीरो किया?
नहीं सर, मैंने पूछा ना मिनिमम के लिए, तो आपने बोला वर्टिकल कंपोनेंट उसका जीरो कर देंगे।
हाँ, जैसे जैसे वो नीचे आता रहेगा ना, उसका नॉर्मल रिएक्शन स्टार्ट टू डिक्रीज। यू नो, इनफैक्ट वो भी करने की जरूरत है नहीं। मेरे ख्याल से ऐसे आ जाना चाहिए। अ, अ, हमारे पास आएगा N1 इज इक्वल टू mg, N2 इज इक्वल टू F1, राइट? और हम अच्छा, नहीं नहीं, तो n इनवर्स 1/2 म्यू, ये वाले क्वेश्चन में मिनिमम एंगल, ये वाले क्वेश्चन में मिनिमम एंगल, मतलब जहाँ पे नीचे दिया हुआ है म्यू और ऊपर नहीं, ऊपर स्मूथ दिया हुआ है, ऊपर में स्मूथ दिया हुआ है। मिनिमम एंगल में प्रतीक्षा, इनफैक्ट वो N2 करने की, जीरो करने की जरूरत भी नहीं है उसमें। मेरे हिसाब से सिर्फ नीचे वाले को, सिर्फ अ, इसको कर देते हैं, N2 करने की जरूरत पड़ेगी ना, N2 जीरो करने की जरूरत पड़ेगी। तो अगर जीरो हो गया तो बचा है क्या? F1 भी zero हो गया। मैं बताता हूँ, सोच के बताता हूँ, बट निकाल सकते हैं, मतलब यू कैन फाइंड द मिनिमम। वी विल, बट हम वो डायनेमिक निकालेंगे, स्टैटिक नहीं निकालेंगे। डायनेमिकली कब वो उसका एंगल छोड़ देता है, वो तो वर्कआउट करेंगे। स्टैटिकली कैसे निकालते हैं, सोच के बताता हूँ।
सर तो लंबा आंसर आ रहा है।
इतना लंबा भी नहीं आना चाहिए कि मतलब। सारी प्रॉब्लम ऐसी ही की है। So first let's get the obvious out of the way. 2 is equal to mu n1 and 1 is equal to m plus mg. Basically this is equal to mu m plus mg. Right. We want the torque to be 0. So I can either take this point or take this point. Torque about 4 is equal to mg है x निकालना है परीक्षा g l by 2 cosine theta plus mg x cosine theta minus n2 l sine theta. So basically I'll end up with mg l by 2 cosine theta plus mg x cosine theta minus or is equal to n2 mu n plus m into g into l into sine theta. Divide throughout.
हाँ सर यही आता है, तो बहुत लंबा जा रहा था चैट पे लिखने
Okay. So I will write it in a shortened sort of incomplete sort of thing, incomplete sort of way. Mu m plus mg l sine theta minus mg l by 2 cos theta divided by mg cos theta. Right, now we can sort of इसको आप वो कर सकते हो.
सर हमने मैन के नॉर्मल फोर्स की जगह पे उसका वेट क्यों लिया?
मैन इक्विलिब्रियम में है ना, तो मैन और लैडर के बीच में जो फोर्स है वो n के बराबर ही होगी. I don't need to say that man is separate from the ladder. I don't need to say that उसमें बस मैं एक एक्स्ट्रा इक्वेशन और एक एक्स्ट्रा वेरिएबल लिख रहा हूँ ना. उसमें मैं लिखूंगा यहाँ पे कैपिटल mg की जगह मैं n लिख दूंगा, और फिर जब मैन के लिए लिखूंगा तो कैपिटल mg इज इक्वल टू n लिख दूंगा. समझा ना?
नॉर्मल रिएक्शन की डायरेक्शन थोड़ी सी
क्या?
टेढ़ी होती ना?
नहीं, टेढ़ी नहीं होगी, बिल्कुल वर्टिकल होगी. मैन अगर इक्विलिब्रियम में है और उसके ऊपर एक फोर्स ग्रेविटी ने लगाई है, तो दूसरा कांटेक्ट फोर्स जो उसके ऊपर लगेगा वो वर्टिकली अपवर्ड्स लगेगा. और कहीं लग नहीं
मैन
सकता.
और लैडर का सीओएम निकाल के फिर एक ही फोर्स का टॉर्क लगा सकते हैं, मतलब एमजी और कैपिटल एमजी को.
यस सर।
मैन और
सर मैन और लैडर
एडर
का
का सेंटर
सीओएम,
ऑफ मास।
हाँ
फिर उसके बाद एम प्लस
हाँ हाँ
एमजी.
हाँ हाँ, यस यस.
सर वो एक ही फोर्स से हो जाएगा।
मतलब ये अच्छा, one more.
सर आप एक बार रिपीट कर सकते हैं आपने अभी भी क्या बोला?
क्या चीज?
सर मेरा शायद कुछ इंटरनेट का प्रॉब्लम हो गया था, मुझे सुना नहीं आपने अभी भी क्या बोला.
हाँ, क्या नहीं सुना शिवन? कहाँ से नहीं सुना?
सर अभी जस्ट लास्ट सेंटेंस में बोला, मेरा मतलब आपका माइक फ्लक्चुएट होते हुए दिख रहा था.
नहीं, मैं बोल रहा हूँ इसको अगर मैन और लैडर का आपने सेंटर ऑफ मास निकाल के और पॉइंट होके अबाउट टॉर्क निकाल दिया, दैट्स आल्सो एक्सेप्टेबल.
क्योंकि फिर इसमें तो एक्स और वाई दोनों एक्सिस से लेना पड़ेगा ना,
क्या चीज?
तो सीओएम मतलब वो कोऑर्डिनेट्स चाहिए होंगे ना,
हाँ यस,
तो फिर बहुत कॉम्प्लिकेट हो जाएगा.
बिल्कुल. हाँ, तो वही मैं बोल रहा हूँ ना कि नहीं एक्चुअली कोऑर्डिनेट्स नहीं चाहिए,
सर
मतलब you
ओ
can
से
always
लेंथ
choose
चाहिए ना
the-
सर वो
हाँ,
डायरेक्टली हो जाएगा।
you can
हाँ
choose
सर
the ladder as the axis ना,
अच्छा हाँ सर, वैसे भी हो जाएगा। ठीक
हाँ
है सर।
ऐसे कर सकते हैं। I would prefer that you don't, but yes you can do it. ऐसा नहीं कि नहीं कर सकते, but ये मेरे को ज्यादा comfortable है। Next question. So this has got nothing to do with ladders and this thing. Just let me draw the diagram. So the question is, मैं पहले पढ़ देता हूँ फिर मैं लिखता हूँ. Stick of mass density lambda per unit length rests on a circle of radius r as shown. Stick makes an angle theta with the horizontal and is tangent to the circle at its upper end. Friction exists at all points of contact and assume that it is large enough to keep the system at rest. Find the friction force between the ground and the circle. So basically what they are saying is that we have a circle of radius r and this angle is theta. The stick or the rod has mass per unit length lambda. So assuming equilibrium and friction at all surfaces, find the force of friction between the ring and the ground. Okay, remember that this guy is tangential to the ring. I hope I've not missed out anything. I'll just read it again.
सर रॉड
Stick
की
of
लेंथ दी है।
नहीं. Stick of mass density lambda per unit length rest on a circle of radius r as shown in the figure. The stick makes an angle theta with the horizontal and is tangent to the circle at the upper end. Friction exists at all points of contact and assume that it is large enough to keep the system at rest. Find the friction force between the ground and the circle. How? Okay. Let me draw. Let's say that here we have F1. Let's say that here we have F2. Let's say that here we have F3 and F3. एक मैंने रिंग पे बनाया, एक मैंने उस पे बनाया, और ऑफ कोर्स इसका जो है यहाँ पे कहीं पे mg भी ऐड करें. आई होप एवरीबडी इसका यहाँ पे कुछ m-g ऐड करना है. I hope everybody agrees with this ability. और एक नॉर्मल रिएक्शन मैंने नहीं बनाया. एक्चुअली मैं नॉर्मल रिएक्शन बनाना नहीं चाहता हूँ, मैं mg भी नहीं बनाना चाहता हूँ. अगर मैं केवल ये फ्रिक्शन फोर्सेस बनाऊं तो कैन यू टेल मी व्हाट इज द रिलेशनशिप बिटवीन दीस फोर्सेस? Anybody tell me what is the relationship between these forces? बहुत बढ़िया शौनक. रीजन क्या है शौनक इसका? हाँ रे, व्हाट इज द रीजन फॉर दिस?
इक्विलिब्रियम कंडीशन.
बहुत बढ़िया, वेरी नाइस. मतलब इक्विलिब्रियम में है तो नेट एक्सटर्नल फोर्स 0 होना चाहिए. नेट एक्सटर्नल फोर्स 0 होना चाहिए, इसलिए F1 is equal to F2. वेरी गुड. F1 is equal to F2 is equal to F. Let's. Can you tell me a relationship between F1 and F3?
F1 cos theta equal to F3.
नहीं. I will write it down here. नहीं आ रहे हैं, गलत है. I will write it down here and you have to tell me why. So a new way of thinking has now emerged for you. Completely different way of thinking. Not only must the forces on the objects be 0, but the torques on the objects must be 0 as well. And the torque on the individual objects must be 0. About any point they must be 0. And the torque on the whole system must be 0. About any point it must be 0. So if I were to choose the ring and only the ring, and if I were to choose this point as the origin, हाँ mg अभी लगाते हैं. mg अभी मैं अलग से बनाऊंगा, प्रतीक्षा तो mg यूज करूंगा. If I were to use only the ring, if I were to consider only the ring, and if I were to consider the center as the, I were to consider the center as the origin, then what are the forces producing the torques on the ring? You see, the normal reaction would produce 0 torque. mg would produce 0 torque. Can everybody see this? Abhi I will draw a detailed FBD, but the normal reaction due to the stick, due to the rod, will be producing 0 torque on the ring because the point of contact of the stick is tangential. Therefore, the normal reaction must pass through the center. The normal reaction due to the ground on the ring must also pass through the center. Therefore, it produces 0 torque. The mg on the ring is acting through its center of mass, which is the center of the ring. Therefore, that must also produce 0 torque. So which forces are in effect producing a torque, a non-zero torque on the ring? Must be F2 and F3. Now F2 is producing a torque of how much? Well, rings are very nice because you apply any force on them tangentially, and the torque due to this tangential force must be equal to force multiplied by radius, because that is the perpendicular distance of the point of action of the force from the chosen origin, if we have chosen the center as the origin. So the torque which is produced by F2 will be equal to F2R, and it will be clockwise. And the torque which is produced by F3 will also be F3R, but it will be anti-clockwise. And these two torques must add up to 0. Therefore, F2 must be equal to F3. ये दिखाई दे रहा है अभी सबको? I hope everybody can see this. This was the uniqueness of the problem, that the friction forces at all surfaces must be the same. This is what you had to conclude. अभी भी किसी को doubt है? I will draw the full. I will draw the full MPD. So this is the ring. This is the rod. Forces acting are N1, F1, F2, N2, काम करना चाहिए. हाँ वही वही ये प्रतीक्षा है. Just say this one. I want to draw them separately. So N3, F3. For the ring, different color. F2, N3, F3, G. यहाँ पे आएगा lambda L. Now please see. I will write it here. Since summation of external along x-axis on the system must be equal to 0. This implies that F1 is equal to F. Since torque about center ring must be equal to 0. F2R minus F3R should be equal to 0. F2 is equal to F. अभी ठीक है? अभी everybody agrees? Anybody having a doubt? Please ask. नहीं तो मेरे को तो कोई ना हाँ बोल रहा है ना बोल रहा है. लो भैया. ओके. और लोग शौनक समझ में आया? सोहम को आया? ओके. महक कहाँ गई? तुलिका
Yes, sir.
समझ में आया? Good. So if we are all, yes, of course, system in equilibrium means all its components should also be. yes. इक्विलिब्रियम का बहुत स्ट्रिक्ट मीनिंग होता है. अच्छा, you mean center of mass equilibrium पे, हाँ, that is also there, that is also possible. That is also possible. But here everything is in equilibrium. So if we are agreed, I will get rid of Okay, so now can you tell me what is the value of f? Basically, f ही तो निकालना है. So first, let's tackle the question of L, length. To tackle the question of length, I encourage you to take up geometry. Last time तक की geometry चाहिए हमको, ज़्यादा तो नहीं चाहिए. Can you find the length of? I think this length can be found. I think the length can be found in terms of r and theta.
Yes, sir.
हाँ, बताओ कितना आएगा, कैसे निकालेंगे, कितना आएगा?
So r by tan theta by 2 आएगा ना?
So the way that you have to do this is realize that this is 90 degrees. You can also drop perpendicular here. This will be 90 degrees. ठीक है? और अगर ये एंगल 90 माइनस थीटा है, ये एंगल थीटा होना चाहिए. Construct another right angle triangle here. So now I know that this distance is r. I know this. And therefore, I can find out this distance. This distance will be equal to what? Tan theta कहाँ से आएगा? तो ये तो सीधा r cosine theta आएगा ना?
सर वो जो पॉइंट है जहाँ रॉड कनेक्टेड है ग्राउंड से और रिंग के सेंटर को अगर हम लोग ज्वाइन करेंगे तो एक
भाई,
एंगल.
तो एंगल भी नहीं पता रहेगा, लेंथ भी नहीं पता रहेगा.
नहीं,
फिर
जब एंगल
साइक्लिक
पता
क्वाड्रिलेटरल लेना.
तो वो थीटा बाई 2 हो जाएगा ना वो जब ज्वाइन कर.
Alternate that, हाँ, yes. So many methods, yes, absolutely. मालूम था यहाँ पे मेरी ज्योमेट्री से अच्छा कुछ. There is something lurking here. So this becomes a what? What is it called? क्या बन जाएगा ये?
तो नॉर्मल राइट एंगल ट्रायंगल है ना और वो जो
नहीं,
एंगल.
कुछ प्रतीक्षा ने कुछ बोला था. साइक्लिक क्वाड्रिलेटरल बन गया ना ये 90 डिग्रीज है, ये 90 डिग्रीज है, नहीं? मतलब I'm sure you can do something with the cyclic quadrilateral. अच्छा, यहीं से निकाला ये थीटा बाई 2 है. बाइसेक्टर है कि नहीं है? ये बाइसेक्टर है ना ये?
सो तो
Yes,
बाइसेक्टर ही होता है.
यस सर, बाइसेक्टर.
अरे होता
सर
है.
दोनों टेंजेंट्स है ना तो फिर
sir,
बाइसेक्टर.
kite है ना.
ओहो, अच्छा. Oh, so nice. फिजिक्स पढ़ाते पढ़ाते जो है मेरा गायब हो गया. ओके, ठीक है. So now you know the length of the rod. कितना आया length of the rod? क्या बोला?
r by tan theta by 2.
R divided by. So we know the mass of the rod now. We know mass, therefore we know mg. We need to find f. So what should I do? किस point के about मैं लूँ? Torque rod पे लूँ या ring पे लूँ? Can you see there is one point that I can take where in one equation I'll get the answer. There is one point from which I will get the answer in one step. नहीं सॉरी नहीं 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 हाँ नहीं नहीं एक बार में नहीं निकलेगा, इसमें वो भी लगाना पड़ेगा आपका क्या बोलते हैं अरे क्या बोलते हैं यार उसको? हाँ वही वही हाँ नहीं 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 एक पॉइंट से नहीं होगा, मतलब यू कैन टेक द टॉर्क ऑफ कोर्स थ्रू वन पॉइंट बट यू हैव टू अप्लाई सम न्यूटन्स एफ इज इक्वल टू एम ए एज वेल, वो भी करना पड़ेगा क्योंकि एन और एन थ्री हमें नहीं मालूम है ना अभी, एन और एन थ्री नहीं मालूम है ना हमको अभी, तो आइदर यू कैन टेक टॉर्क अबाउट 2 points, that should help.
तो जो पॉइंट जहाँ पे रॉड कनेक्टेड है ग्राउंड से, वहां से ले सकते हैं ना सर, क्योंकि वहां से हम लोग को मतलब N3 की वैल्यू आ जाएगी, N3 और N2 की, क्योंकि वहां पे
नहीं
सारे F जो होंगे वो तो जीरो हो जाएंगे उनका टॉर्क।
नहीं 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 वहां पे अगर टॉर्क लेगा ना तो एन थ्री का टॉर्क आएगा और जो ऊपर वाला एफ है उसका भी तो टॉर्क आएगा।
सर सर लेकिन वो तो डायरेक्टली उसके थ्रू, अच्छा ठीक है सर, हाँ ठीक है समझ आ गया सर।
तो हम लगाएंगे इसमें कोई इतना मुश्किल नहीं है, रॉड के ऊपर आप लगाओ ना न्यूटन सेकेंड लॉ लगाओ ना, आराम से आंसर आएगा। वर्टिकल लेना है या हॉरिजॉन्टल कोई भी एक्सिस ले लो, आराम से आंसर आएगा। So we know that this angle is theta. We know that this angle is theta. Right. Therefore, these angles are also known, right? This is theta, 90 minus theta, this is theta. Therefore, this is theta. So you can just quickly f cosine theta, f sine theta. Right. And what you can do is you can take torque about this point O. So if you take torque about the point O, then you get mgl by 2 into cos theta is equal to n3 वाला टॉर्क आएगा, n3 into L कैंसिल हो गया, n3 की वैल्यू आ गई mg cosine theta upon 2, right? Now you can just equate the horizontal forces, that's it. I don't need to calculate n1. So if I calculate the horizontal forces, I will get f plus f cos theta is equal to n3 sin theta. Let's put n3 here and we'll get the answer. आंसर का मैं वैल्यू बता दे रहा हूँ।
सर ये एंड में आपने क्या किया, एक बार रिपीट करोगे क्या? मैं डिस्कनेक्ट
बिल्कुल
हो गई
आखिरी में लेफ्ट वाला ना,
थी। हाँ सर।
मैंने केवल रॉड के ऊपर हॉरिजॉन्टली मैंने फोर्सेस को जीरो कर दिया। रॉड के ऊपर आप सारे हॉरिजॉन्टल फोर्सेस देखो।
यस सर, समझ गई।
इसका आंसर आएगा lambda gr cos theta by 2. F will come out to be f will
सर
come out.
N1 और N3 एक्सटेंडेड पे हमने पॉइंट क्यों नहीं लिया?
हाँ, फिर से बोलो बच्चा।
सर वो जो N1 और N3 को एक्सटेंड करके जो पॉइंट आता है,
नहीं समझ में आया। N1 N3 को एक्सटेंड करेगा तो क्या मिलेगा?
सर वो एक उनके इंटरसेक्शन पे एक पॉइंट आता है ना, वो
हाँ, तो वहाँ पे क्या करेगा?
सर वहाँ पे टॉर्क 0 नहीं होगा N1?
ओह वेरी नाइस। हाँ, वहाँ पे टॉर्क 0 ले ले, एक स्टेप। वेरी नाइस। सोचा ही नहीं। So either you can extend N1 and N3 and oh that is the single point जहाँ से oh मैंने गलत नहीं बोला था, सही बोला। चलो ठीक। In HCV the torque 0 does not start from the beginning, right? I have started from equilibrium, but in HCV they don't start from equilibrium. So I wanted to skip that stuff, and I think from question number 40 or 42 they start with the equilibrium questions, very ladder wale questions, and around 8 or 9 questions are given for equilibrium. So ये जो 8 or 9 questions हैं, please do them before the next class, and from the next class then we'll start with angular acceleration वाले problem. Angular acceleration हो रहा है. Just as a homework, I would like to give you another question, which is a continuation of this one basically. I'll just read it out. I'll just read out the question and I'll draw the diagram also. A large number of sticks with mass density lambda per unit length and circles with radius r lean on each other as shown in the figure. Abhi main figure banata hu. So basically what is happening is, I'll just change the slide. So basically what is happening is that now you have a stick, and then you have a circle, and then you have another stick, then you have another circle, you have another stick, then you have another circle. So ये एंगल थीटा है, ये रेडियस r है, इसका मास पर यूनिट लेंथ लैम्डा, सेम एवरीथिंग इज सेम. A large number of sticks with mass density lambda per unit length and circles with radius r lean on each other as shown. The sticks are hinged to the ground now, and every other surface is frictionless, unlike in the previous problem. Okay. Every other surface is frictionless. In the limit of very large number of sticks and circles, what is the normal reaction between a stick and a circle it rests on? Very far to the right. Assume that the last circle leans against a wall to keep it from moving. So this time, the last circle is kept against a wall so that everything is in equilibrium. And these are hinged now. And there is no friction. Find n between a stick and a circle very far to the right. So there is equilibrium, and you have to find the normal reaction. Okay, okay. So try this at home. Try this, and we'll discuss this in the next class. चलो ठीक है guys, so I'll leave you now and we'll meet in the next class. ठीक है ना, मैं जा रहा हूँ.
थैंक यू सर.
बाय बाय. ये Zeal Academy. चलो guys, बाय बाय बाय.